Understanding unit prefixes is just as important as understanding units. Prefixes tell us the scale of values. So it's really important to understand what values we're actually looking at and how we can relate two sets of units with each other. We're going to take a look at common prefixes and how we convert from one unit prefix to another. Here we have a list of common unit prefixes. Right? This left column is the naming convention. We name it first, the prefix, and then the variable or property that we're looking at afterwards. So let's say we're looking at a Pascal, pressure or stress term. We'd say gigapascal, right? So prefix gets named first. If we're looking at a length scale, like a meter, we'd say nanometer, millimeter, and so forth. This middle column is a symbol. So you write down the prefix first, and then the symbol for the unit variable afterwards. So a Pascal is represented as PA. So if I want a gigapascal, I would write the symbol G and then PA. If I look at a millimeter, I would write little m for milli and then little m for meter. If I'm looking at a nanosecond, I would write little n for nano and then little s for second. And then this far right column is the power, right? 10 to what power? So if I'm looking at a megapascal, 1 megapascal is equal to the power 10 to the 6th of a pascal. So these are large value unit prefixes. Down here we have small value unit prefixes. So if I'm looking at a nanometer, right, one nanometer is equal to 10 to the negative 9 times a meter. So a very small length scale. That's how we use the prefixes, symbols, and powers. Now, depending on what field you're looking at, what area you're focusing on, certain prefixes are more common than others. It really is there to make your life more convenient, right? So in my experience, I don't use tera very often, right? The only time I really hear about tera is terabyte. But giga, mega, I use often for strength of materials. A gigapascal, a megapascal, or pressure terms. Kilo, I use for kilometers, or kilonewton for force terms. I personally don't use hecto, deca, or deci often at all. But that doesn't mean other engineering fields or science fields don't use them. I just don't use them very often. Centi, milli, we use often for length scale, like centimeter, millimeters, micrometer or micron, nanometer for length scale as well. Pico, I've only used for like a small time scale, picosecond. But it depends on what you're looking at, which ones you'll be using. Now, the purpose of a unit prefix and understanding how to utilize unit prefixes is the same reason why we need to understand units to begin with. You need to be able to understand what values you have and how to work values with different properties. So let's take a look at a few examples of converting some of these basic units with different unit prefixes. So let's start in a simple one. We have 0.001 meters, and I want to convert this into centimeters. Okay, so I can use this table to help me recognize the relationship between meters and centimeters. So meters has no prefix, so that's the base unit. Centimeters has the base unit of meters again, but centi is my prefix. So I go centi and I say 10 to the negative 2. So a centimeter is smaller than a meter. So the number that goes in front of centimeters, because it's a smaller unit, will be a larger value. Should be larger than 0.001, the number I get. All right, so let's take a look. So I have my original number, 0.001 meters, and I can multiply that with a unit value. When I say unit, I mean a single value, a value of 1. So if the numerator is equal to the denominator, that's a value of 1. And the goal is to drop out this unit of meters and replace it with centimeters. So I know I need to divide by something with in unit of meters, and I need to multiply in units of centimeters, right? So looking at this power right here, this tells me that 1 centimeter is equal to 10 to the negative 2 meters. So 10 to the negative 1 divided by 10 to the negative 2 is the same thing as multiplying this value by 10 to the positive 2. So the nice thing of scaling with powers of 10, then I can just move the decimal point, right? So I move a decimal point by 2, 1, 2. This is 0.1 centimeters. This number is larger than this one, and that's consistent with the units going from a larger value to a smaller set of units. All right, another way of looking at this, instead of saying how many meters are in the centimeter, I can look at how many centimeters are in the meters. Well, that's just basically flipping it, right? So instead of saying 10 to the negative 2 meters, we're saying 10 to the power 2, or 10 squared centimeters is equal to 1 meter. So then in this case, I'm moving it again by 2 decimal places, 1, 2. So either way you want to work it is fine. In the beginning, to avoid confusion, I would suggest picking one method. Are you going to use the power and multiply that by the base unit, or do you want to flip it, right? Pick one method and just consistently use that method, recognizing the other method also is there and it works the exact same way, but picking one method will make your life easier and you won't make the mistake. The most common mistake is having the wrong sign in your exponential exponent, right? And so instead of saying 1 centimeter is equal to 10 to the negative 2 meters, a common mistake would be 1 centimeter is equal to 10 squared meters. Obviously, that doesn't make sense here. So if you do a sanity check just by looking at your values at the very end, you shouldn't have less centimeters to equal a certain number of meters, right? So just doing that sanity check will help you make sure you're doing or working in the correct unit prefix conversions. Let's take a look at another example. Here we have 500,000 psi pressure unit, pounds per square inch. And I'm going to convert this into KSI, right? Kilopounds per square inch. All right, so PSI is my base unit, kilo pounds per square inch. That's my kilo is my prefix. Kilo here is 10 cubed. So I want to convert PSI, so I divide by PSI, my base unit. How many PSI is in one KSI? 10 cubed. So I put 10 cubed here and 1 KSI here. So 500,000 PSI is equal to 500 KSI. This makes sense. My value gets smaller. My numeric value got smaller here, the value in front of the units, because the unit itself got larger. PSI is smaller than a KSI. So the numeric value got to be smaller for these to be equivalent. Okay? 2.5 gigapascals, a pressure term again, and I want to convert this into megapascals. So in these two examples, we start with the base unit. Here, we have a prefix in front of our base, and we want to convert to a different prefix of the base. There's two ways we can look at this type of problem. I'd say convert to the base and then convert to the new prefix, right? That's the first step if you're not sure. So how do we do that? We have two conversions here. So 2.5 gigapascal, that's my original term, okay? So I want to convert this into pascals. So I look giga, 10 to the 9th. So I need to divide by gigapascals so that I can convert back to pascals, right? Kind of got to drop this term out. So 1 gigapascal is equal to 10 to the 9 pascals. So now I got my base unit in pascals. Now I want to convert this into megapascals. Megapascals is 10 to the 6. So I divide by pascals and then multiply by megapascals. 1 megapascal is equal to 10 to the 6 pascals. So I got 10 to the 9th and then 10 to the 6. The gigapascal term is going to drop out here. Pascal is going to drop out here. So we're going to be left with megapascals. So I got 2.5 times 10 to the 9th divided by 10 to the 6. Knowing the rules of exponentials, you know 10 to the 9th over 10 to the 6, you could just subtract those exponentials. So 10 to the 9 minus 6, or 10 cubed megapascals. And 10 cubed, you can also rewrite moving this 3 decimal spaces. 2,500 megapascals. The other way of doing this is you look at, all right, I'm going from giga to mega, giga to mega. There's a difference in 10 cubed. So I can write 2.5 gigapascals, 1 gigapascal, that's a larger value, is equal to 10 cubed megapascals. So you can do it in one conversion if you like, and obviously you get the same value. I would say if this is the first time really doing these unit prefix conversions, start here and then recognize the patterns that can allow you to convert in one step, right? The more you do these problems, the faster you'll be able to see the conversion between them, right? And a lot of these are scale 3, right? 10 to the 9th, 6 cubed, the base, and then milli, micro, nano, pico. So you can see the patterns that actually do arise with these prefixes. All right, 34 picoseconds, and we want to convert this into milliseconds. So 34 picoseconds, 1 picosecond is 10 to the negative 12, right? There's a power, seconds. Then you want to convert seconds into milliseconds. 1 millisecond is 10 to the negative 3 seconds, right? So there's picoseconds cancels, seconds cancel, and then we're left with milliseconds. 34 times 10 to the negative 12 over 10 to the negative 3. This is negative 12 minus 3 gives you 10 to the negative 9th. Okay, so I'm going to give you a few examples. Press pause, try to solve them, and then we'll walk through the solutions together. All right, so let's say I have 100 centimeters. I want to convert that into nanometers. I have 12 kilonewtons. I want to convert this into millinewtons. I have 0.2 microwatts, and I will convert this into kilowatts. And I have 0.15 terapascal, and I will convert this into a gigapascals. So press pause, then come back, and let's see if you match, right? Look at the pattern that we follow here, see if you can follow that same pattern. Okay, so hopefully you tried solving these unit prefix conversions. Let's start here. 100 centimeters, I want to convert into nanometers. Centi, 10 to the negative 2, nano, 10 to the negative 9. So 100 centimeters, 10 to the 9th nanometers over 10 squared centimeters, right? So if you want to convert directly and you don't want to make this multi-step approach, you do it all in one step. Now, if you don't want to think about what the direct conversion between nanometer and centimeter is, this is the way you can do it, right? So what's the thought process here? It's basically this setup here. If I want to go from centimeters to meters, and I want to only focus on my prefix, not my base, then I'll flip the sign here. So instead of 10 to the negative 9, I write 10 to the 9th nanometers. Instead of 10 to the negative 2 for centimeters, I write 10 squared centimeters. This is basically saying 10 to the 9th nanometers is equal to 1 meter, and 1 meter is equal to 10 squared centimeters. So we're just taking out that base unit conversion. If you did the other way, that's fine. You should get the exact same solution, right? So 10 to the 9th over 10 squared, 9 minus 2 is 7, so 10 to the 7th nanometers. I got 100 times 10 to the 7th nanometers. So this is equal to 2 plus 7 is 9, so 10 to the 9th nanometers, equivalent there. Okay? So similarly, I got 12 kilonewtons. So kilonewton, kilo, 10 cubed. If I want to write in this form, I can write this as 10 to the negative 3 millinewton. Instead of 10 to the negative 3, I write it as 10 cubed. So 12 times 10 cubed minus 3. So 3 plus 3 gives me 6. So 10 to the 6 millinewtons, or 12 times 10 to the 6 millinewtons. Here are 0.2 microwatts, and I want to convert this into kilowatts. So micro, 10 to the negative 6. So if I want to do it in this form, 10 to the 6. Kilo, 10 cubed. So I want to do it in this form, 10 to the negative 3. So 0.2 times 10 to the negative 3 over 10 to the 6. So this will be 10 to the negative 3 minus 6 10 to the negative 9. So 0.2 times 10 to the negative 9 kilowatts. And then finally, 0.15 terapascal to gigapascals. Tera is 10 to the 12th, so I'll write 10 to the negative 12 terapascal. Giga, 10 to the 9th, so 10 to the negative 9th gigapascal. So 10 to the negative 9, so negative 9 minus negative 12, that's gives me positive 3. So 0.15 times 10 to positive 3 gigapascals. Or I can move this decimal 3 spaces, 1, 2, 3. So 150 gigapascals. So we could do a sanity check on these. Centimeter units is larger than a nanometer unit. So this number right here, 100 centimeters, should be a larger value when we go to nanometers, because this is a smaller unit scale. So you need more of those, okay, which it is. Kilonewton is a larger unit than a millinewton. So you have 12 of these. So the number that goes in front of this should be larger. So this is 12 times 10 to the 6. It is larger. That's consistent. Microwatt, kilowatt. Microwatt is a smaller value than a kilowatt. So the number in front of kilowatt should be smaller than the one in front of the microwatt, which it is. You have 10 to the negative 9. Terapascal is a larger unit than a gigapascal. So the number in front of the gigapascal right here is going to be larger than the value, the unit that goes right here. So it's the kind of, if the units get smaller, then the value gets larger. If the unit gets larger, then the value, the numeric value gets smaller, right? They're equivalent, right? We're trying to make equivalency. All right, so hopefully this unit prefix conversion makes sense. Hopefully the previous video of the unit conversion makes sense. With that and following just the basic patterns, you should be able to do any kind of unit conversion once you know the rules and you're using a consistent pattern to make your conversions, right? A lot of people will do it in different ways, but as long as you're consistent in how you do the conversions, you shouldn't make any mistakes. All right, so good luck. Put in any comments or questions you might have below.